Welcome back to Mastering MHA MBA. We're continuing Chapter 8 from Datar and Rajan's Managerial Accounting, determining how costs behave. This is part 2 of 3. In part 1, we described how costs behave. In part 2, we moved to the harder question: what causes them to behave that way, and how do you estimate the relationship from real data? Quick recap. In part 1, we covered learning objectives 1 and 2, linear cost functions in their three forms, nonlinear cost functions, and the three criteria for classifying any cost. Today, learning objectives 3 and 4, the importance of cause and effect when picking a cost driver, and the 4 methods managers actually use to estimate a cost function from data. Here's the shift. In part 1, we were given a cost structure, 3 pricing alternatives from a vendor, and we wrote each as a function. In real life, managers rarely get a clean term sheet. They have past costs and past activity, and they have to figure out which activity actually drives the cost. Sony does this when evaluating design choices for new TV models. Volkswagen does this to forecast next year's customer service budget. Better cost predictions only happen when managers correctly identify the factors that move costs. Learning objective 3. The most important issue in estimating a cost function, more important than the math, more important than the software, is determining whether a cause and effect relationship exists between the activity and the cost. Without that, every prediction is fragile. Datar and Rajan list 3 sources of a real cause and effect link. First, a physical relationship. Producing more snowboards requires more plastic, period. Second, a contractual arrangement. Canon's video conferencing minutes from part 1 caused the bill because the contract said so. Third, knowledge of operations. A Lenovo laptop with more parts incurs higher ordering costs because that's how procurement actually works. Any one of these is enough. Without at least one, you don't have a cost driver, you have a coincidence. Take Winston Furniture. They make granite-topped and wooden tables. Granite has high material cost but low labor cost. Wooden is the reverse. Sell 20% more of each, and total direct material cost and total direct labor cost both rise 20%. They look perfectly correlated. Now flip the mix. Sell 6,000 fewer granite tables and 14,000 more wooden tables. Total volume still grew 20%, but labor cost goes up more and material cost actually falls because wooden tables flip the ratios. Direct labor cost is correlated with material cost in the first scenario, but it does not cause it. Use direct labor cost to predict material cost and you'll be wrong every time the product mix shifts. The lesson: high correlation between two variables does not mean one causes the other. They may both be driven by something else. In Winston's case, the volume of each product type. Economic plausibility, a story about why the relationship should hold, is what separates a real cost driver from a statistical artifact. Without the story, the relationship may show up in your training data and disappear in next quarter's data. A practical rule: when identifying cost drivers from past data, use a long time horizon. In the short run, costs are often fixed because contracts and headcount don't move. In the long run, those same costs become variable and their drivers become visible. Look only at 3 months of data and you'll conclude that supervision cost has no driver. Look at 3 years and you'll see exactly what drives it. Translating this into a hospital: imaging supplies, the driver is number of scans, not patient days. Pharmacy compounding labor, driver is the number of unique compounded doses, not total prescriptions filled. Coding and billing labor, driver is the number of unique encounters, not gross charges, because the work is per encounter. Sterile processing, driver is surgical cases times instrument trays per case, not total inpatient days. The wrong driver here will mislead every budget meeting for the rest of the fiscal year. Keys to success from the textbook. Before you estimate any cost function, verify that an economically plausible cause and effect relationship exists between the activity and the cost, and do that estimation over a long enough horizon to see the relationship. Skip either step and the regression that follows is just decorated correlation. To see how cost drivers fit into a real decision, follow Elegant Rugs through the 5-step decision process from Chapter 1. Elegant Rugs makes carpets on automated weaving machines. Management has changed the manufacturing process and wants to introduce new styles. Have indirect manufacturing labor costs, supervision, maintenance, quality control really gone down? And which new styles should they launch? Data and Rajan walk through each of the 5 steps. Let's follow. Step 1. Identify the problem. Comparing total indirect manufacturing labor cost before and after the process change is misleading because volume and product mix also changed. The question becomes, how do those costs relate to activity, and did the relationship shift? Step 2. Obtain information. The team gathers data on candidate cost drivers, machine hours, direct labor hours, number of batches, and starts considering the estimation techniques we'll cover in a moment. Step 3. Make predictions. Use the estimated relationship between cost drivers and costs to forecast the cost of each candidate carpet style. Step 4. Decide. Spoiler: managers will choose machine hours as the driver and use a regression equation we'll meet in part 3 to predict cost per machine hour. Then introduce the most profitable styles. Step 5. Implement and learn. After a year, compare predicted to actual costs. If your prediction was tight, replicate the process. If it was loose, refine the cost driver or the model. Learning objective 4. 4 methods for estimating a cost function. They differ on cost to implement, the assumptions they require, and how much they tell you about the accuracy of the estimate. They are not mutually exclusive. Most organizations use a combination, and Datar and Rajan recommend using more than one as a check on the others. Let's go through each. First method, industrial engineering, also called the work measurement method. It estimates a cost function by analyzing the physical relationship between inputs and outputs. At Elegant Rugs, time and motion studies might show 1 hour of direct manufacturing labor produces 10 square yards of carpet. Standards and budgets convert those physical measures into dollars. Bose and Nokia use it for direct manufacturing costs. Some US government contracts mandate it. Strength: it's the most rigorous method when there's a clear physical link between inputs and outputs. Weakness: it's expensive and slow, and it breaks down when the cost is something like research and development, advertising, or general overhead, where you can't time and motion your way to a clean answer. In healthcare, time and motion studies work well for sterile processing cycles or imaging suite throughput. They struggle with case management, social work, or quality improvement. Second method, the conference method. You estimate cost functions by gathering opinions from people across departments: purchasing, engineering, operations, HR. The Cooperative Bank in the United Kingdom runs a cost estimating department that builds cost functions for retail banking products this way, by consensus from departmental staff. Elegant Rugs uses it by polling supervisors and process engineers about how indirect manufacturing labor responds to machine hours and direct labor hours. Strength: fast, cheap, and cross-functional. Pulls expert knowledge from across the value chain, which gives the estimate political weight inside the organization. Weakness: it is opinion, not data. Accuracy is bounded by the care and skill of the people contributing. In a hospital, this looks like a budget meeting where the OR director, anesthesia, and pre-admission testing each give their take on how case mix shifts will affect supply costs. Third method, account analysis. You estimate a cost function by going through each cost account and classifying it as variable, fixed, or mixed with respect to the chosen activity. The classification is qualitative. Managers and management accountants use experience and judgment, not statistics, to make the calls. The textbook example. Elegant Rugs runs a small production cell. Over the most recent 12 weeks, the cell ran for 862 machine hours and incurred $12,501 in indirect manufacturing labor cost, supervision, maintenance, quality control, setups. The team uses qualitative judgment to declare this a mixed cost with one driver: machine hours. Through experience and conversation with operations, the manager and accountant separate the $12,501 into a fixed component of $2,157 based on the cell's 950 hours of capacity over those 12 weeks, and a variable component of $10,344 The variable rate is 10,344 divided by 862 machine hours, $12 per machine hour. The cost function, y equals 2,157 plus 12x. Use the function to forecast. At 950 machine hours, predicted indirect manufacturing labor cost is 2,157 plus 12 times 950, $13,557. Notice the per machine hour cost falls from $14.50 historically to $14.27 prospectively. That's the fixed cost spreading over a larger base. This is the same dynamic that drives every "we need higher volume to cover overhead" conversation in healthcare. Strength. Account analysis is widely used because it is reasonably accurate, cost-effective, and easy. Many service organizations rely on it. Weakness. It depends on the analyst's judgment. Pair it with the conference method to broaden the input. The textbook's recommendation, supplement, don't replace. Fourth method, quantitative analysis. You fit a cost function to past data using a formal mathematical method. Excel makes this easy. Exhibit 8-4 shows 12 weeks of paired data, machine hours, and indirect manufacturing labor cost for the same elegant rug cell. We'll use this exact data set in part 3 to walk through two specific quantitative techniques: the simple high-low method and the more powerful regression analysis. Strength. Quantitative analysis is the most rigorous of the four. It's objective. Same data plus same method gives the same answer. And it lets managers compare candidate drivers head to head, which we'll do in part 3 with two competing drivers for elegant rugs. Weakness. It requires clean paired data and the time to clean and analyze it. In a hospital that has decent data warehousing, it's the right tool. Without that data infrastructure, account analysis or the conference method is often the realistic choice, a practical synthesis for the MBA context. Direct supplies, industrial engineering, because the input-output link is clean. Sterile processing labor, quantitative analysis on case data with account analysis as a sanity check. Case management or care coordination labor, conference method, because the work is judgment heavy and process driven. New service line research and development, almost always conference plus account analysis, because there's no historical data to regress against. Match the method to the cost. To recap, the most important step in estimating any cost function is establishing economic plausibility, a real cause and effect link between the activity and the cost, and doing it over a long enough horizon to see the relationship. Four methods exist: industrial engineering for physical input-output relationships, conference method for judgment-heavy contexts, account analysis for fast and reasonable estimates, quantitative analysis for rigor. In part 3, we go deep on quantitative analysis, the 6-step process, the high-low method, regression analysis, how to choose between candidate drivers, and the data quality problems every analyst runs into. Thanks for watching Mastering MHA MBA, based on Datar and Rajan's Managerial Accounting, 1st edition.